This problem is designed to show us how to use our rules for means and standard deviations in continuous and in discrete situations. We have an assembly line, and we are bringing a part from a bin to its position on the car, and that has a mean of 11 seconds and a standard deviation of 2 seconds. Then the worker has to attach the part to the car. That has a mean of 20 seconds and a standard deviation of 4 seconds. The first question is, what is the mean required? What is the mean time for the entire operating process of positioning and attaching the part? So my new mean is going to be bringing it from the bin and attaching it. And if I take a look at my old mean from the bin, it was 11 seconds with a standard deviation of 2 seconds. We should call that sigma. And attaching the part was a mean of 20 seconds with a standard deviation of 4 seconds. So the new mean of adding these positioning and attaching together would simply be 11 plus 20, or 31 seconds, because means are nice to work with, and they behave as we expect them to be. The next question asks, if the variation of the worker's performance is reduced by better training, the standard deviation will decrease. Will this change the mean you found in Part A? If you're only reducing variation, then that is working on the spread, and it's only going to change the standard deviation. So the answer to Part B is no. Only sigma and sigma squared, which is the variance, will decrease. And our final question, it finds that the times required for these two steps are independent, and that key word means that we can now combine our standard deviations. However, we found out through the rules that standard deviations do not combine. So the standard deviation from the bin, which is 2 seconds, and the standard deviation of attaching, which is 4 seconds, the first thing we need to do is change those into variances, which will give us 2 squared, or 4. And the standard deviation of attaching will give us 4 squared, or 16. So I don't want to be using the standard deviations to find the new standard deviation. I actually want to use the variances. The new variance of the bin plus the attaching, according to our rules, we can add those. So 4 plus 16 gives us 20. And now going back to standard deviation, I take the square root of 20, which is 2 radical 5, or using the calculator, we would get 4.472, or 4.47 seconds.